determinants. In this module, you will learn about determinants. You may know that the area of a triangle formed by the points x1, y1, x2, y2 and x3, y3 is the numerical value of the expression half x1 into y2 minus y3 whole plus x2 into y3 minus y1 whole plus x3 into y1 minus y2 whole. You can also represent this expression by a square arrangement between two vertical lines. Such an arrangement is called a determinant. The condition for a second-degree equation in x and y to represent a pair of straight lines can also be expressed in the determinant form. Thus, a determinant is used to express a long equation concisely. The term determinant was introduced by the mathematician Carl Friedrich Gauss. It was named so because it determines the properties of quadratic forms. A determinant is associated with every square matrix. Unlike a matrix, it can be reduced to a number. Let us see how. Consider a 2 by 2 matrix. We need to find its determinant. First, write the square arrangement of numbers between two vertical lines. Now make the diagonal from top to bottom and find the product of the numbers along this diagonal. Similarly, make the diagonal from the bottom to top and find the product of the numbers along this diagonal. Now, subtract the two products. The difference represents the value of the determinant. Thus, the determinant of a 2 by 2 matrix is the difference between the product of the numbers lying along the diagonals from top to bottom and bottom to top respectively. Now, if we name this matrix A, then A between the two vertical bars represents the determinant of a matrix A. The determinant of A can also be denoted by det A or delta. Now let us learn to find the determinant of a 3 by 3 matrix. We can find the determinant of a 3 by 3 matrix in two ways. First, by applying S.R.P's rule. Second, by expansion using minors or cofactors. S.R.P's rule is a shortcut to compute the determinant of a 3 by 3 matrix. So, we'll center our attention on this method. Consider a 3 by 3 matrix. We need to compute the value of its determinant. First, copy the first two columns on the right side of the determinant. Now make all the three diagonals from top to bottom. Find the product of the numbers along these diagonals and add the products. Next, make all the three diagonals from bottom to top. Find the product of the numbers along these diagonals and add the products. Now, the difference between the sum of the products of the diagonals from top to bottom and the sum of the products of the diagonals from bottom to top gives the required value of the determinant. This is how S.R.P's rule works. It is important for us to remember that we cannot use S.R.P's rule to compute the determinants of higher order matrices such as a 4x4 matrix. In this module you have learnt that the determinant of a matrix is a number associated with every square matrix. The determinant of a 2x2 matrix is the difference between the product of the numbers lying along the diagonals from top to bottom and bottom to top respectively. The determinant of a 3x3 matrix is the difference between the sum of the products of the diagonals from top to bottom and the sum of the products of the diagonals from bottom to top. This is called S.R.P's rule.